Yeah, welcome. The topic we'll be discussing in this lecture is merge sort. So, so the basic principle of merge sort is given a two sorted arrays, given a two sorted arrays, it will merge that. It will merge the two sorted arrays and and it will ensure that that merged array is also sorted. Okay, but the input to arrays should be sorted. Okay, so that is what shown here. So basically it takes two sorted lists as input. Okay? Lists, for otherwise you can call it as array. Two sorted lists, this point is important, it is a sorted list. So this is the first sorted list, okay, or you can call it as list 1, sorted list 1, and this is the second sorted list 2. What it does in the sense, it combines these two lists and it creates a single sorted list. So this is what basically merge sort does, right? And it achieves a time complexity of order of n log n in worst case and also in average case. So which means that it is better than quick sort. Quick sort worst case time complexity is order of n square, whereas best case and average case is order of n log n. Whereas for merge sort, everything it is order of n log n. Okay. Now let us see in detail how it works. So the basic principle is given a two sorted list, it produces a merged sorted list. Okay, this is the basic principle. What is it? Given a two sorted list, given two sorted lists, sorted lists, what merge sort does in the sense, it it produces a single combined sorted list. It produces a single combined sorted list. Okay, right. So this is the key aspect of merge sort. So first let us try to understand this in more detail. Given two sorted list, the merge sort will produce a single combined sorted list. Okay. So it should have two sorted list as input, right? So let us assume that we have two sorted lists. List 1 is something like this, say 6, 7, 8 and 9. Okay, this is list 1. Say list 2 is something like this, 1, 2, 3, 4 and 5. This is list 2. Okay, so this is list 1. List 1 is now sorted, right? This is list 1 which is sorted. List 2 is also sorted. Now if you want to apply merge sort on it, then the merge sort is supposed to create a combined list. The combined list should be capable of holding how many elements? It should be capable of holding the number of elements that is in list 1 plus list 2. List 1 contains 4 elements, list 2 contains 5 elements. So it should be capable of holding 9 elements. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Right? Now how merge sort works, that we'll see. Okay, so we will be maintaining two pointers. We'll be maintaining two pointers. What is in the sense, one is called as I, the other one is called as J. Okay, these are not pointers, these are not literally pointers, these will point to respective array index. Okay, so let us say that I points to this list 1, this is list 1, and J points to list 2. Okay, J points to the first location of list 2, that is 0th location. Okay, this is 0, this is 1, 2, 3, 4 index locations of the array of list 2. Similarly for list 1, this is 0th position, this is first position, this is second position, this is third position. Now what you have to do in the sense, or what the merge sort does in the sense, it just compares the the element at ith position of list 1 with the element at jth position of list 2. If the element at ith position of list 1 is less than the element at jth position of list 2, okay, then what you have to do is copy the content of list I, okay, list 1. Copy the content of ith position of list 1 to this new array. Okay, let us call this new array is n. Okay, that is, if this element is less than this element, copy this content and increment I. Otherwise, copy this content and increment I. Okay, so how can we write the code for this? The code for this will be something like this. If L1 of list 1, okay, if L1 of I is less than or equal to L2 of J, okay, then what you have to do is n, okay, n of, say here for n we maintain a variable k, okay, say initially k is pointing to this 0th position, okay, so n of k, or we'll say n of k plus plus, after n of k plus plus is L1 of I, okay, that is when, if this element, if the element at the ith position of list 1 is less than or equal to the element of jth position of list 2, then do this. Otherwise n of k plus plus will be equal to L2 of j plus plus, okay, that is, after that j will increment, here also after that I will increment, okay, so this is not I, this is I plus plus, this is not I, this is I plus plus, okay, so this is I plus plus, okay, I think it's clear, right? So you compare the first element of this list 1 with the second element of with the first element of list 2, okay, if the first element of list 1 is less than the second element of first element of list 2, then copy the first element of list 1 to the new array, otherwise copy the first element of list 2 to the new array, okay, whichever the thing you are copying, that pointer should be incremented. So now if you see 6 is not less than 1, 1 is less than 6, so copy 1 and increment j, so now j will point here, I is not incremented, I is still the 6 only, okay, again compare, is 6 is less than 2, now j is pointing to first location, no, 6 is not less than 2, so again copy the current element at jth location of L2 to the new array and increment j, so now j will point here, again compare, I is still here only, the first element of L1, that is 6, is it less than this current jth element of L2? No, it's not less than, so copy the jth element of L2 to the new array, so 3 will come here and increment j, so j will point here, again compare whether the ith element of L1 is less than or equal to the jth element of L2. No, it's not less than or equal to, so copy the jth element of L2 to the new array and increment j, so j will point here to the fourth location, again compare the ith element of L1, is it less than or equal to the jth element of L2? No, 6 is not less than 5, so copy the jth element of what do you call, copy the jth element of L2 to n and increment j. Now when you increment j, it goes beyond the capacity, okay, so when it goes beyond, you should come out, when it goes out, no, you should come out. After coming out, what you have to do in the sense, whatever the element that are left out in list 1 or list 2, that you have to copy here, okay, so now you, what are the element, all the elements starting from first you, so in j everything is copied to the new array, so from I, whatever the left out element, you should copy to this new array, okay, so 6 will come here, then increment I, 7 will come here, then increment I, 8 will come here, then increment I, 9 will come here, again if you increment this has exceeded the limit, so stop, are you getting? So now we got a combined list. Okay. So basically this is what merge sort does. This is the basic principle how it works. It takes two sorted lists and it produces a combined merged sorted list. Okay, fine. Now let us see how it is going to sort a given set of numbers. Now let us see how merge sort is going to sort a given set of numbers. Say for example, we are given with these numbers. Okay, say we are given these numbers like 10, 9, 8, 7, 6, 5, 4, 3, 2 and 1. So this we want to sort in ascending order. Okay. Now what merge sort will do in the sense, actually we have 10 elements. We have 10 elements. But merge sort, or how it will work in the sense, it will first it will treat individual element as a separate list. Okay, it will treat individual element as a separate list or a separate array. So now we want to sort 10 elements. So merge sort will take it as 10 different lists. Merge sort will consider this as 10 different lists. Okay. So it will not consider it as one list, it will consider it as 10 different lists. So you are not having, you don't have one list, you have 10 different lists. Okay. So now what merge sort will do in the sense, you merge sort will apply the merge sort logic for this list and this list. You know what is merge sort logic? So now this is list 1, this is list 1 and this is list 2. List 1 contains only one element, list 2 also contains only one element. Now you have to apply merge sort on this and you have to produce one combined list. Okay, so I will be pointing to 0 and j will be pointing, I will be pointing to 0th position of L1 and j will be pointing to the 0th position of L2. Now compare whether the ith element of L1 is less than or equal to the jth element of L2. No, 10 is not less than 9. So copy 9 here. Okay, copy 9 here and increment j. When you increment j, it will go beyond the limit because it has only, this list has only one element. Okay, so now when it goes beyond the limit, what you have to do, whatever the element left out in the other list, that should be copied. Okay, so 10 will come here. Okay, so this is how we do. Okay, so now we have merged these two lists into one single list, right? Similarly, next we have to merge these two lists. Now consider this as L1 and this as L2. Now this is one separate list, this is another separate list. For this list I is 0, j is, for this list j is 0. So again you check whether the now this is not L1 and L2, this is L1 and L2. Okay, whether the ith element, okay, I is 0 here, for L2 j is 0, whether the ith element of L1 is less than or equal to the jth element of L2. No, so copy the jth element here of L2 here and increment j. When you increment j, it goes beyond the limit. So whatever the leftover element of list 1, copy it here. So this is the combined list which you have created out of these two lists. Similarly do for this 6 and 5. So when you do for 6 and 5, what you will get? 6 and 5 is, so you will compare like 6 is less than 5. So this is L1 and this is L2. No. So 5 will be coming here and 6 will come here. Okay. Similarly do for 4 and 3. When you do for 4 and 3, again if you compare whether 4 is less than or equal to 3. No. So copy 3 here and then after that if you increment j, it will go beyond the limit. So in the, from the other list you copy the remaining element here. So there is only one element, so 4 will come here. Similarly do for the last two list with single elements 2 and 1. Okay, so when you do for this, is 2 is less than or equal to 1? No, so copy 1 and when you increment this j, it will go beyond the list, beyond the limit. So from the other list copy the next element. Okay, so this is the end of the first iteration of the outer loop, you can say. Okay, so now the program contains how many lists? Originally you see it contained 10 lists. Okay, now the number of lists is reduced to 1 2 3 4 5 lists. Okay, So you should keep continuing until you are left out with only one list. How long this process should continue means you should keep on doing until you are left out with one list only. Okay. Now similarly you merge these two lists. This is a sorted list and this is a sorted list, right? So you merge these two lists. Okay. So now this is L1, this is L1 and this is L2. Okay. This is 0, this is 1, this is 0, that is this is 0th index of L2, first index of L2. This is 0th index of L1, first index of L1. Okay. Initially I will be 0 and j will be 0. Okay. Okay, check whether the zeroth element of L1 is less than or equal to the I mean whether the ith element, that is zeroth element of L1 is less than or equal to the jth element of L2. J, this is j. Okay. No, 9 is not less than 7. So copy 7 and increment j. So j will become what? 1. Okay, now I is not incremented. So again check whether the ith element of L1 is less than or equal to the jth element of L2. I is 9, j is 8. No. So copy 8 and increment j. So j will become 2. But this array contains only up to values only up to first location. There is no 2. So you come out. If there is any remaining element in L1, copy it here. Yes, there are few elements 9 and 10. Okay. So now these two lists were merged. Similarly, merge these two lists. So when you merge these two lists, what will happen? Now this is L1, this is L2. Okay. 0 1 0 1. I is initially pointing to 5 and j is pointing to 3. So check whether the ith element of L1 is less than or equal to the jth element of L2. No. So copy the jth element of L2 to this array. 3 will come here and increment j. So now j will point here. So now compare the ith element of L1 with jth element of L2. Whether 5 is less than or equal to 4? No. So copy the jth element of L2 here, that is 4 will come here. Okay. And now when you increment I will go beyond the limit because this array has only two elements, that is up to index 1, but it goes beyond that. So stop doing that and now copy the remaining elements from L1 to this new array. So the remaining elements are 5 and 6. Okay. Similarly, if you compare here, there is no other array to combine, right? There is no other list to combine. So this we will keep as it is because it does not have only with the right side we will be merging. Okay. We do not have any other further arrays to merge. Okay. So this is the end of the second iteration of the outer loop. Now we are left out with how many lists? 3 lists. Okay. Again continue the process. Now these two lists we should merge. These two lists we should merge. Okay. So now this is L1, this is L1, this is L2. Okay. So you know this is 0, 1, 2, 3, 0, 1, 2, 3. Okay. Say I is initially pointing to 0th location of L1 and j is pointing to 0th location of L2. Check. Is the ith element of L1 is less than or equal to the jth element of L2? This is 7. Okay, this is 7. No. So copy the jth element of L2 to the new array and increment j. So j will point here. Again check. Is the ith element of L1 is less than or equal to the jth element of L2? No. So copy 4 here. Again check and increment j. Is the ith element of L1 is less than or equal to jth element of L2? No. This is 7, this is 5. 7 is not less than 5. So copy 5. Again check. Is the ith element of L1 is less than or equal to jth element of L2? No, 7 is not less than 6. So copy 6. I mean now, okay, again if you, after copying 6, if you increment j, j will go beyond limit. J will become 4. We don't have any 4. This element contains maximum, this array contains maximum 3 elements. So stop doing this and whatever the leftover element from this array, you copy here. So what you will get? 7, 8, 9 and 10. Okay. And this, again this list, we don't have anything else to merge in the right. So we retain as it is. So at the end of third iteration, we have two lists. Okay. Now next we should combine these two lists into one list. So now this is L1. Okay, now this is L1 and this is L2. Okay, L1 contains many locations, very many values like 0, 1, 2, 3, 4, 5, 6 and 7. L2 contains 0 and 1. So I is pointing to 0th location of L1 and J is pointing to 0th location of L2. So check whether the ith element of L1 is less than or equal to jth element of L2. No, ith element of L1 is 3, jth element of L2 is 1. So 3 is not less than 1. So copy the jth element of L2 in this new array and increment j. So j will point here. Again compare whether the ith element of L1 is less than or equal to jth element of L2. No. So copy the jth element of L2 here and increment j. So now when you increment j, j will become 2. Okay, j will become 2, that is it crosses the limit. As it has crossed the limit, we have to stop this process and copy the any leftover element from I to this array. So all these are the leftover elements. Okay, so 3, 4, 5, 6, 7, 8, 9 and 10. Okay, so now we have got one single sorted list. Okay, so this is how merge sort works. Okay, so this is the crux of merge sort, right? Fine. So how we are going to implement it, that is the question. Okay, see, before that, one more thing I want to say. Here we have copied always only j, but it is not that case. Sometimes we may copy I also. Okay, say how can, say, let us take one situation for that. Okay, let me take a different situation. Okay, I just wanted to share that info also. Assume that first array, first list contains this element, say 2, 4, 8 and 9. This is sorted, right? This is sorted. Okay, say second list contains, what can we keep here? Say second list contains yeah 6 we'll keep here. 6, 7, say 12 and 13. Okay, 12 and 13. Fine. Let us see like this. Okay, say this is L1, this is L1, this is L2. Okay, 0, 1, 2 and 3, and yeah 0, 1, 2, 3. Okay, so I is pointing here, j is pointing here. So you will compare like whether the zeroth element of I is, whether the ith element of L1 is less than or equal to jth element of L2. Yes, in this case you see ith element of L1 is less than jth element of L2. So now you have to copy what ith element. So 2 will come here and increment I. Increment I. Okay, again you compare. Now j is not incremented. Again compare the ith element of L1 with jth element of L2. Is it less than, is the ith element of L1 is less than or equal to jth element of L2? Yes, 4 is less than 6. So copy the ith element of L1 into the new array and increment I. So I will point here. Okay, again now you compare whether the ith element of L1 is less than jth element of L2. No, now I is 8, j is 6. It's not less than. Okay, it's not less than, right? So what you have to do, now copy jth element of L2 to the new array and increment j. So now j will point here. I is remaining same. Okay, is the ith element of L2, L1 is less than or equal to jth element of L2? No. So copy jth element to the new array, jth element of L2 to the new array and increment j. So j will point here. Now is the ith element of L1 is less than or equal to jth element of L2? Yes, 8 is less than 12. So copy 8 here and increment I. Now is the ith element of L1 is less than jth element of L2? Yes, 9 is less than 12. So copy 9. Now what you have to do, now you have to increment I. When you increment I, it goes beyond the limit. Okay. So you have to copy the leftover element of J, L2 here. What are the leftover element? 12 and 13. Are you getting? Okay. So how we are going to write this logic? How we are going to write this logic in the sense, see this is basically two arrays, okay, right? This is two arrays, but logically you can also consider this as one array, uh, but what you call, but we are considering as two partition. One array we are considering as two partition, that way also you can take, okay. So now you have to know what is the starting position, what is the mid position, and what is the end position. All this information you should know. Okay, we should know the starting point, which you can call it as lower bound. You should know what is mid position. Okay, and also you should know what is upper bound. Okay, so this array, if you see, it contains how many elements? 1 2 3 4. This contains 5 6 7 8. Okay, so the starting, if you combine these two arrays to single array, I mean, it is not what you call, still it is a different, in a single array you consider as different partition which is not yet merged together. Okay, this is one partition which is sorted, this is another partition which is sorted, but we have to merge. If you think that way, then this we can call it as 4. Okay, we will call only one name, say L. Okay, not L1, say just L. But this is one portion of the array which is sorted. This is another portion of the array which is sorted, but it is not yet merged. So this will be 5, this will be 6, and this will be 7. Okay. In that case, what is LB? Lower bound is 0. What is mid? Mid is this last location of the first partition, that is 3. Okay, that is mid. What is upper bound? Upper bound is the last location of the second partition, that is 7. This is upper bound. Okay, right? From this we can derive certain things, like we can say that I is equal to lower bound. Okay, which means I is equal to 3. J is equal to mid plus 1. J is equal to mid plus 1, which means J is equal to 4. Okay, N is equal to upper bound, which means N is equal to 7. Okay, right? With these details, let me try to write the code for this. Okay, so how we will write the code to merge these two things? Not only, yeah, merging these two things in a sorted way, and if any leftover is there, that should be copied. Remember that also we should do. Okay, so that code, how can we write? So how can we write means, while I is lower bound. Okay, I less than or equal to J, while I less than or equal to mid. Okay, mid. Okay, I will end at which point? Mid. Okay, so here we will also add mid is equal to 3, it's there. Okay, so while I less than or equal to mid, this I pointer which is for the first partition of the array. Okay, it can go up to mid, and j less than or equal to, j is starting with mid plus 1. Okay, I starts with 0, and j is less than or equal to n, j ends with n. Okay, what you have to do, see, this array we are calling as L, and this array we are calling as N. Okay, there is no, yeah. So these two are combined now. Okay, these two are combined, only this is one partition, this is another partition. Okay, but we want to merge these two partitions. So what logic here we have to write is, if L of I less than or equal to L of j. Okay, if the ith element is less than or equal to jth element, then what you have to do in the new element, so here we will maintain one more variable k is 0. Okay, in the new array, in the kth location, k plus plus is equal to what? L of I, ith element will come. Else in the new array, k plus plus, that is after placing increment k. Yeah, here also I plus plus. Okay, L of, this is L of j plus plus. Okay, if ith element is less than or equal to jth element, then copy the ith element at kth location and increment I and also increment k. Otherwise, copy the jth element at kth location and increment j and also increment k. Okay. So this is the while loop. After coming out of while loop, what you have to check is if I less than mid. Okay, if I becomes less than mid, what it means? What does it mean? It means that all the element of I was copied into the array, but there are some element of j may be left out. So that should be copied. So for that, what you have to write is while this is if is true. Okay, while j less than or equal to n. Okay, this is n is the upper bound. While j less than or equal to n, again n of k plus plus n of k plus plus is equal to L of j plus plus. Okay. This is when if I is greater than mid. Else, suppose I is not greater than mid. Okay, I am writing here else. This else corresponds to this if. Okay, if I is not greater than mid, which means what? If I is not greater than mid means some of the element from the this partition of the array is not yet copied into the new array. Okay, any one may happen. Okay, not both will happen. So what you have to do? While I less than or equal to mid, right? While I less than or equal to mid, what should we do? N of k plus plus equal to L of I plus plus, right? Okay. So this is the core logic which is going to do merge sort. Okay, this is the core logic which is going to perform merge sort. Right. Let me open the notepad and let me write this code as a separate function. Okay. Okay, now we can write it as a function. So this becomes the core logic void merge. It takes three parameters. What are they? It takes a lower bound, it takes mid, okay, and it takes upper bound. All these as arguments. Okay. Then here we maintain int I is equal to lower bound. Mid we won't change. Mid is mid only. Int j is equal to mid plus 1. Okay. Int n is equal to upper bound. K is equal to 0. Okay. Then write the logic. While I less than or equal to mid and j less than or equal to n, what should we do? What should we do? If say the array name is, say that original array name is A, okay, instead of L I am calling it as A. Okay, if A of I less than or equal to A of j, okay, then what should we do? Copy into the new array. So let us call the new array is B. Then B of k plus plus is equal to A of I plus plus. Okay, I will be incremented, right? Otherwise, what you, if suppose if A of ith element is not less than or equal to A of j, then what we will do? Else what should we do? B of k plus plus, B of k plus plus is equal to A of j plus plus. This is the logic, right? Now after copying, maybe some of the elements from one of the partition of the array may not be copied fully. Okay, that also we have to copy. So for that, after coming out, we check if I is greater than mid. If I is greater than mid, it means that all element from the left partition is fully copied. Okay. In that case, the right partition, the jth partition may not be copied. So while j less than or equal to n, what we do? B of a of k plus plus, okay, equal to a of j plus plus, okay. This is if I greater than mid. Else suppose I is not greater than mid, I is less than mid in the sense, then some element of I might not be copied into the new array if I is actually less than or if I is not even equal to mid, if I is less than mid, okay. Then while I less than or equal to mid, okay, what should we do? B of k plus plus is equal to a of I plus plus. So that's it. This is the crucial logic of what you call this merge sort, okay. But this is not everything. But this is not everything, okay, because this logic, what it does, given a two list, when you are given a two list, it just merges it into a single list, okay. uh, but you have to, but if you see the explanation what we have discussed, if you recall, first we take the first two elements and we sort that, then we take the next two elements and we sort, then we take the next two elements and we sort that. So how are we going to do that? Okay, for that actually we have to write another function. For that we have to write another function. So we'll call that function is void merge sort, okay. This function will take three arguments. One is LB, the other one is UB, the other one is S. Okay, what is this S in the sense? See, what is this S in the sense? I'll explain this, because this S is the crucial thing which you should know to understand how merge sort works. Okay. So let me take an example, then only it can be explained. So let us go back to our original example, okay, in which we have discussed like what do you call 10, 9. I'll quickly rewrite that: 7, 6, 5, 4, 3, 2, 1. Okay. So what we in the first iteration it becomes 9 and 10. This becomes 7 and 8. This becomes 5 and 6. This becomes 3 and 4. This becomes 1 and 2. Okay. So that is this is one list. This is one list. This is one list. This is one list, and this is one list. Okay. Originally, everything is considered as a separate list. This is everything is considered as a separate list. Okay. In the first case, everything is treated as a separate list. Now we combine this thing. This is 10, right? Sorry, this is 10. No, it's 10, 9, 10, 7, 8. Okay. So now it becomes 7, 8, 9, 10. Okay. This becomes 3, 4, 5, 6. This is 1, 2. Okay. Now this is one list. This is another list. This is one list. Okay. In the next iteration, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So this is one list. This is one list. And this is another list. In the next iteration, this all the things will be combined. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, this entire thing is a one list. Okay, right. So now I'm that use of that S term, for that I'm explaining this. Okay, because in coding that plays a crucial role. Okay. So in the first iteration, if you see, everything is a separate list. Okay, everything is a separate list, right? So what happened? So we repeated that operation for how much times? I mean the loop. If you see the what do you call the number of iterations we have to find out. Okay, so it contains 10 elements, means first we took everything is considered as an individual list. So totally how many lists are there? In this case 10 lists are there. So we continued up to this list. Okay, that is first we compared okay, we'll call this as what you call, if you call this as a 10th list, then we compare 10th list is 9th list, then 8th list with 7th list, 6th list with 5th list, 4th list with 3rd list, okay, then second list with first list, okay. So we compare, I mean, see, totally there are 10 lists, okay. So we came up to 9th list. Number of comparisons, no, not number of comparisons, it's exactly not number of comparisons. uh, when there are 10 lists, okay, the loop should repeat for 9 times, okay. That is, when there are n list, the loop should repeat for n minus 1 times, okay. That you remember, okay. Because because when there are 10 lists, we have did this for 9 times, okay, right. 9 times means up to this second element we compared with first, okay. So yeah, right. Are you getting? So when there are n elements, the first iteration should go up to n minus 1 times, okay. It should go up to n minus 1 times, right. Mm, okay. Or and when and during the second time, if you see, during the second time, after first iteration, the list is reduced to how many? 1 2 3 4 5. There are only 5 lists, okay. So now we are going to repeat this process for how many times? We are going to see, this is not n times. What you can say in the sense, it is not n times. Yeah, I'm sorry for that. It is not n time until I is less than or equal to this 9. That many times the loop should repeat, okay. Because it contains how many list? 9 n list. So the loop should repeat until I is less than or equal to n minus 1, okay. I, how we will increment in the sense, see in this case, so for incrementing I only, there s plays a crucial role, okay. So that's what I'm trying to say. See here, initially I will be 0. So 0th list, if this is 0th list or this is 10th list, whatever it may be, let us assume 0th list. Then 0th list will be compared with first list, okay. These two comparisons happen at the same time. Then I will become 2. Second list will be compared with third list. Then I will become 4. Fourth list will be compared with fifth list. Then I will become 6. Sixth list will be compared with seventh list. Then I will become 8. Eighth list will be compared with ninth list. When I becomes 10, you should come out. Okay, so that is what this n says. Okay, when you should come out, as long as it is less than or equal to n minus 1, it is okay. Okay, n minus 1 is what? 9. If it becomes greater than n minus 1, you should stop that process. Okay. In the first case, I should be incremented by 2 because each list contains only one element. Okay, so I should be incremented by 2. But if you see the second case also I will start with 0. I will start with 0. Okay, but here this is one list and this is one list. Okay, so this list we are going to compare, with this list. In one iteration we do this comparison. We compare 9 with 7. If it is 7 is less, so keep here. 9 with 8, 8 is less, so keep here. Then copy 9, 10, all these things. Then during the next iteration I should become what? This is 0, 1, 2, 3. I should become 4. I should become 4. Are you getting? Then we will compare this list and this list. Then in the next iteration I should become what? This is 4, 5, 6, 7, 8. I should become 8 here. Are you getting? Similarly, now these two lists were merged to this list. These two are merged like this. This is merged like this. Now here also I will start with 0. Okay, I will start with 0. Now this list will be compared with this list. After comparing and merging, now I should increment how much? I should increment 8. 0, 1, 2, 3, 4, 5, 6, 7, 8. So in the second iteration directly I should become 8. Are you getting? Okay, right? When you come here, I will start with 0. Okay, but this will be compared with this. But after that I should become 16. but it will come out of the loop. That is not an issue, but it should become 16. Okay, like that I should increment. In different iteration, the way in which I is incrementing is different. Okay, for that we maintain a variable yes. For that we maintain a variable yes. Initially when you call this for the first time, this yes will be 1. This yes will be 1. Okay, and I will be always incremented something like this. I is equal to I plus s into 2. Okay, when s is 1, if you increment I like this, what will happen? When s is 1, if you increment I like this, what will happen? If you start I with 0, when I is 0, okay, when first time I is 0, second time what will happen? I will become 2. Okay, third time I will become 4, then 6, 8. This is the pattern we want for the first iteration of the outer loop. Okay, in the second case, what we do in the sense, now second, when you call second time, now s will be made into s into 2. Okay, so previously s is 1 means now s will become 2. Now also we apply the same thing. Okay, I will start with 0. That first iteration will be 0. That will not be disturbed. Okay, during the next iteration only this formula will be applied. So what will become 0? Then second time when it goes, now s is 2. So 2 into 2 what? 4, 8, 12, 16. That rate it will go. Okay. Next time I will become what? S will become what? S equal to s into 2. That is previously it is 2. So now it will become 4. So I will be incremented like what? 0, 4 2s are 8. 0, 8, 16. Okay, so on and so forth. It's a multiple of 8. Next time s will be what? 8. Previous s into 2. Okay. So I will be what? 0, 16. That rate it will go. Okay. So that is the reason we maintain that yes. Okay. That is the reason we maintain that yes. Okay. So initially s will be 1. Right. Initially s will be here 1. Okay. Now here we will write a for loop. For I is equal to 0, comma j is equal to 0. Okay. j j less than or equal to j less than or equal to n represents number of elements. Okay, let us assume n represents the originally, or you can say initially how many lists are there. That is equal to number of elements, right? Okay, n by s. Okay, n by s minus 1. Okay, as long as j is less than or equal to n by s minus 1. Okay, then what we will be doing, this is the what do you call, this is the terminating condition. Okay, as long as j is less than or equal to n by s minus 1, we will be keep doing what we will be keep doing. Every iteration I will be incremented like this: I plus equal to s into 2. Okay, I is equal to I plus s into 2, right? Yeah. Okay, so from here you will be calling that merge. From here we will be calling the previous logic is merge logic. Okay, so here from here we will be calling merge, but what you have to pass, you have to pass the lower bound, mid and upper bound. All these things you have to pass, right? So how are we going to do that? Yes, so for that what we do in the sense, so lower bound will be I. Okay, lower bound will be I, right? Mid how are you going to calculate in the sense I plus s minus 1, this is mid. Okay, I'll show how it is. Okay, and n is I plus 2 into s minus 1. Okay, this is n. Okay, why it is so? Again you have to come back to the logic here. See, initially we are going to initially all these are individual lists, right? So I is 0. I is 0. Now we are going to combine two lists. First two lists. Okay, what is n? N will be, I mean upper bound. Okay, lower bound is 0. Lower bound is 0. N is nothing but upper bound. Upper bound will be 1. Okay, that is fine. What is mid? Mid will be 0 plus 1 by 2. 0 plus 1 by 2 is what? That is 0 0.5, but you scale down, okay, that is you take floor of it, that is 0, right? So it is what, zero, you can call it as 0 0 1, okay. 0 is lower bound, this 0 is mid, and this 1 is what, upper bound, okay. When you come here, lower bound is 2. 2 and 3 should be compared, right? Lower bound is 2, upper bound is 3. What is mid? 2 plus 3 by 2. 3 plus 2, 5. 5 by 2 is what? 2.5. Floor 2.5. So again it is what? 2, 2, 3. Lower bound, middle, upper bound. This is lower bound, this is middle, upper bound. Similarly, if you see this, okay, next iteration 4 and 5. Okay. So lower bound is 4, upper bound is 5, middle is 5 plus 4, 9 by 2. 4.5, that is 4. So again it is 4, 4, 5. Lower bound is 4, middle is 4, upper bound is 5. Next, if you take this 6 and 7, lower bound is 6, upper bound is 7. So 6 plus 7 is what? 13. 13 by 2 is 6.5, that is 6. Okay, that is if you take floor. So 6 comma 6 comma 7. So lower bound, middle, and upper bound. Similarly, if you do for 8 and 9, you will get 8 comma 8 comma 9. Okay, that is upper bound is, sorry, something is happening. Yeah, upper bound is 9. Okay, upper bound is 9. So 8 plus it is 8 plus 9 by 2 is, it is 9 plus 8 is 17. Okay, 17 by 2 is 8.5. So what you get is 8, 8 comma 8 comma 9, right? So how are we getting this? How can we get? So we have to, write a code like that. In every iteration we should get that properly. So this is when we consider each list as a separate one. When you come for the second iteration, okay, now what is lower bound here? This is a separate list, this is a separate list. These two lists we are going to merge and we are going to combine a single list. So lower bound is 0, upper bound is 0, 1, 2, 3. Okay, upper bound is 3. Mid will be what? 0 plus 3 by 2. 3 by 2 is 1.5, that is 1. Okay, so it will be 0 comma 1 comma 3, right? Similarly, if you see this, lower bound is 4, 4, 5, 6, 7. Upper bound is 7, 4 and 7. Mid is 7 plus 4 is 11. 11 by 2 is 5.5, that is 5. 4, 5 and 7. Are you getting? So how we are going to do this? Okay. So updating I will be taken care by yes. This logic will ensure that I is correctly updated. So we will get L correctly. Okay, that is lower bound we will get correctly. But we want mid and upper bound. Okay. For getting mid, what we are doing is we are doing I plus S minus 1. That is what we are doing. So here in this case S is 1. Okay. Throughout this case, throughout the top case, S is 1. Throughout this case, S is 2. Throughout this case, S is 4. Okay. Throughout this case, S is 8. Okay. Are you getting? Throughout this case, S is 16, but here we will not continue, right? So when S is 1, what you have to do? It is I plus S minus 1, that is mid. So I we know, right? I plus S is 0. I is 0, 0 plus 1 minus 1 is this, that we got mid. Okay, similarly here when you come here, I is 2, S is 1, 2 plus 1, 3 minus 1 is 2. Okay, similarly here I is 4, 4 plus 1 is 5, 5 minus 1 is 4. Okay, I is 6, that is lower bound is 6. 6 plus 1, 7, 7 minus 1 is 6. Here I, that is lower bound is 8, 8 plus 1, 9 minus 1 is 8. Similarly when you come here, S is 2. Okay, I is 0, that is lower bound is 0. I plus S is 0 plus 2, 2. 2 minus 1 is 1. Right? Here when you come, I is 4, that is 4. 4 plus S is 2, 4 plus 2, 6, 6 minus 1 is 5. So this will ensure that our mid is accessed correctly. Okay. Similarly for N, what we are doing, I plus 2 into S minus 1. Okay. So this will take care that N is accessed properly. Okay. So what is here, if you see n is 1, okay, so s is 1, 0 plus 2 yes, 0 plus 2, 2 into 1 is 2, 0 plus 2 is 2, 2 minus 1 is 1, okay. Similarly 0 plus 2 yes, 0 plus 2, sorry, this is 2, okay, I is 2, I is 2, 2 plus s is 2, 2 plus 2 4, 4 minus 1 is 3, okay. Similarly here 4, 4 plus 2, 6 minus 1 is 5, so on and so forth. If you come here, I is 0, s is 2, okay, so 2 into s is 2, okay, 0 plus 0 plus 2, 0 plus uh, so I plus 2s minus 1, right, 2s, yeah, so s is 2, so 2 into 2 4, okay, so 4 minus 1 is 3. Similarly when you come here, 4 plus 2s, that is 4 plus 4 8, 8 minus 1 7. So that is how that n thing we should correctly access, okay. For that we are following this logic, okay. So when you do like this, what happens, first iteration when I is, I mean when you call this for the first time, okay, actually this function itself will call several times. When you call this for the first time, you s will be 1, okay. When s is 1, what it will do, it will call merge for, it will call, you assume s is 1, okay. If s is 1, if s is 1, then I will increment like what, first time I is 0, second time I plus s into 2, so I will be 2, third time 3, 4, 6, 8, like that it will go, okay. So it is going to merge what, 0 and 1 first, okay. This loop will repeat for 9 times, okay. This loop will repeat for 9 times. So what it will do, uh, it will I mean it is supposed to continue for this much times. So uh, uh, okay, here it is not uh, yeah, okay. So this loop will continue for 9 times or whatever it may be. Then first time when it calls it will merge 0 and 1, next it will merge 2 and 3, okay, next it will merge 4 and 5, next it will merge 6 and 7, next it will merge 8 and 9, okay. So that's what it is going to do, right. So in s is 1, okay, n is 10, 10 by s minus 1, okay, right, okay. So I think this need not be j, this can be I, okay, this can be I, yeah. So this again, this function you have to call from another function, void, okay, let us call it as c merge, okay. So so here we will again declare l int lb comma int ub, okay. Here actually we will maintain what you call, here we will maintain that s will be initially 1, s will be initially 1, and while lb is less than ub, as long as lower bound is less than upper bound, okay, we will continuously call merge sort, continuously call merge sort of lb comma ub comma s, okay, which will call this, and that in turn will call the other function, and then we will update s equal to s into 2, okay. Every iteration we will update s equal to s into 2. So this is the logic, okay. And probably from main function, void main, here you will declare an array, okay, read the input for the array, and from here you call, say, otherwise say we have an array something like this, a of 10 is equal to some element 10, 9, 8, 7, 6, 4, 3, 1, okay. This array contains how many elements, 10 elements, 0 to 9. So from here we can call c merge of 0 comma this logic will take, right? Now let us see the code. Let us see the code. This is the code. Okay. So this is the code here. Yeah. Yeah, so sorry, this is while s less than n, right? S less than n. Okay. As long as s is less than n, we will continue that process. So this is the code, whatever we have discussed. Actually, we will maintain two arrays. One is A, which is the one which we are going to merge sort, and the result will be stored in B. So this is n, which is used to hold the number of values in the array. All these are declared globally. These two are the print functions which I did for checking. One is for printing the B array, another one is for printing the A. Yeah, only one print function is there. Okay, fine. And this is the actual merge sort logic which we have discussed. LB, mid and UB. So whatever we have discussed, the same thing. Sometimes this UB may go beyond the limit, so that I have written this logic here. If n is greater than or equal to capital N, then n is equal to n minus 1. Okay, we are not allowing n to go beyond that, right? Then this is the logic whatever we have discussed. While I less than or equal to mid and j less than or equal to n, a of I less than or equal to a of j, b of k plus equal to a of I plus plus. Let's do this. After coming out, if I is greater than mid, then copy the remaining elements from j into b. Otherwise, copy the remaining elements from I into b. Okay. Okay, and then this code you have to write. Why we are writing now? This after sorting every time, we are updating in the new array B. In the new array B, okay. But whatever we have sorted, that we will copy to A. So here you can see I is equal to 0, I less than upper bound we are using. So whatever this upper bound, first time this upper bound will be, lower bound will be 0 and upper bound will be 1. So only two values will be sorting properly, but that two values will be copying in the original array, that two values alone. Okay, for I is equal to 0, I less than ub, right? So this is required actually. Okay, fine. Then this is the merge logic. It takes LB, UB and S. For I is equal to 0, j equal to 0, j less than or equal to C of n by s minus 1, I plus s into 2 and j plus plus. Okay, merge sort of I plus I comma I plus s minus 1, then I plus 2 into s minus 1. Okay, this can also be I less than or equal to C of n by s minus 1. I think it is not going to make any difference with that, right? You can also keep it with I. And this is C merge. I think these variables are yeah, s is 1 initially, n is ub, okay, or instead of n you can use ub directly, and I is not required here. While s less than n we call merge of lb comma n comma s. Okay, that is nothing but ub, same, right? And s is equal to s into 2, right? And here is the main function. Here we ask the user to enter the number of elements, then we read the elements, then we call C merge of 0 comma n, and finally print the result. Okay, so let me execute. Ten, 9, 8, 7, 6, 5. So you can see here, see, I will show you a smaller example. Say we'll try with 7 elements. 7, 6, 5, 4, 3, 2, 1. You can see here first what is happening. This 6 and 7, okay, got fixed properly. Then this 5 and 4 become 4 and 5. Then this 3 and 2 becomes 2 and 3. Then this 1. Okay, this is the one iteration. One iteration of what? This loop. Okay, when this loop is called once, Okay, when this loop, I mean, so you can consider there are three loops. You can consider there are three loops. This while is the outer loop. Inside that this is this for, okay, and then this thing is executing. For is in turn calling this, okay. So this when this while loop, when this outer loop, there are three loops, okay. When this outer loop while completes for one time, this is what you are getting, okay. What you are getting 6 7 4 5 2 3 and 1. When that innermost loop, when it executes for the first time, it is 6 7. When it executes for the second time, 4 5. When it executes for the third time, 2 3. Then this, okay, like that. You are getting right. So similarly, when the innermost loop, when the outermost loop again repeats for the second time, what happens here? You see 6 7 4 5 2 3 1. Okay, then now we take these two things, okay. It becomes what? 4 5 6 7, right? 4 5 6 7 2 3 1. 4 5 6 7 1 2 3 4 5 and 1 2 3 4 5 6 7. That is 4 5 6 7 and 1 2 3. 4 5 6 7 is taken as one part, 1 2 3 is taken as another part, okay. So like that it is merging, right? Okay. Actually I want to discuss the recursive version also, but already it is taking time. So recursive version we'll discuss in the class, okay. So let us stop here. Okay, thank you.